Alright, in this video I want to explain specifically number 4. It's very important that we be able to couple this concept, this motion graph concept, with what we've already talked about just recently with horizontal projectiles. So I'm going to review how we need to analyze each of these graphs and what they mean in a horizontal projectile problem. First of all, let's remember that we had a projectile. This was for the lab where we did we launched a marble out of the marble launcher. Okay, so here was our cannon, and we launched a marble, and it eventually hit the floor at some point. Right, and you had to calculate the distance in the x direction. I gave you delta D in the y direction, and then you also had to figure out what this velocity was here to begin with. So that's the problem that we're working with. It's a horizontal projectile. We've got to remember that in the x direction there is constant acceleration, or sorry, constant velocity. In other words, there's no acceleration. Acceleration is 0. And in the y direction we do have some acceleration because of gravity. In the y direction, acceleration is negative 9.8 meters per second squared. Okay, the projectile will speed up in the y direction as it nears the ground because of the influence of gravity. In other words, there's a force in the y direction. Forces that are unbalanced cause acceleration, but there's no forces in the x direction as long as we neglect air resistance. So once this marble leaves the cannon, there's no forces that are acting. Therefore, whatever speed it leaves at, Vx, that's the Vx it's going to keep. That's the x component of the speed that's still going to happen all the way through the entire flight of the ball. Alright. So the question now is, how does that apply to these graphs? Specifically, the question says, sketch each of the following graphs to describe the ball's motion in the air. We want to know about horizontal distance, dx, versus time. So that would be a distance versus time graph, and I need a new pen. Horizontal distance versus time, and that will be this graph here. We want to know vertical distance versus time. This graph here, see, this is x and this is y. Horizontal, so I'll just say horizontal, vertical. Horizontal speed versus time, that's this graph here. Speed versus time graph. So this is a velocity time graph now. And then vertical speed versus time, x, y, horizontal speed, vertical speed. So we need to, let's first of all review, what do these graphs represent? Okay, slope was one thing that we needed to consider in each of these graphs. Remember that slope represents what in a distance versus time graph? Think about that for a second. What does slope represent on a distance versus time graph, also known as a position or displacement versus time? What does slope represent? Well, hopefully you remember that the slope represents velocity. So I'll just say that right here. Slope represents velocity on a distance versus time graph. Both of these. Same question on velocity versus time. What does the slope of a velocity versus time graph represent? Think about that for a second. What would your answer be? And if you said that the slope represents acceleration, you would be correct. Slope of velocity time graph represents acceleration. If you don't remember how we came up with that, you might want to go back and view the videos again on motion graphs. So if slope represents velocity, I want to know what the slope is going to look like, and so I need to figure out what the velocity is doing in the x direction. Okay, what is the x velocity like? Well, we just talked about a projectile, and in the x direction I asked the question, is there any acceleration? Well, the answer is no, because there's no forces going on in the x direction. If there's no acceleration in the x direction, we have constant velocity. And if the velocity is constant, the slope should also be constant, because slope represents velocity. So if we have a constant slope, you should know right by now that it should be a straight line. Okay, but the question is it going to look, if this is distance versus time, is the line going to look like this? Is it going to look like this, or is it going to look like this? Think about that for a minute, or if you're sitting next to a partner here in class, talk to your partner about that for just 1 second. All right, let's talk again. Let's remember that the slope represents velocity, and the only thing that's different among these slopes is that, first of all, this one doesn't have a slope, this one has a positive slope, and this one has a negative slope. And remember, with a distance versus time graph, the direction or the sign of the slope gave us the direction of the motion. So the question is, what direction was our projectile moving? Well, in the x direction, we gave it a positive velocity, so it better have a positive slope, which means it's not this. And it's not going to be this either, because hopefully you remember that on a position versus time graph, a straight horizontal line means that the object is not moving. In other words, this line, velocity is 0. Well, we know the projectile was moving in the x direction, so we know that this can't be it. Can't be this one, it can't be this one, so it has to be this line right here. It's a straight line because x speed is constant. And the line will also start from 0 because we decided that where the projectile started out was the 0 position. Now, I want you to talk with your partner for a minute, or if you're at home, just think about it. Pause the video for a second. Use the same vein of thought we used here and consider what a distance versus time graph in the y direction would look like. Pause the video now. All right, if you were able to do some thinking, let's use the same vein of thought. If we look at a distance versus time graph in the y direction, the question is, in the y direction, what does velocity do? Hopefully you remember that velocity in the y direction increases because of gravity. So if the velocity increases, we should also have a slope that increases. So this is not going to be a constant slope anymore. There are not going to be any straight lines here. That's not going to happen. We're going to have a constantly changing slope. The slope needs to change. In other words, this is going to be a curvy line. It's going to be a curved line. And another question to ask yourself is the velocity in the y direction positive or negative? Well, the object is dropping, so that's going to be a negative velocity. So we know it's a curved line. And the question is it this? Or is it this? And hopefully you understand why it's not this, but tell me why it can't be this. Talk with the person sitting next to you, or think to yourself, among these three, which one is the answer and why are the other two not the answer? Pause the video now and think about that. Alright, we know it can't be the middle line because the middle line is a straight line, which is a constant slope, which means constant velocity. In the y direction, velocity is not constant, so this cannot be the case. In the y direction, we have constant acceleration. The object will speed up because of gravity. So it's got to be one of these two. The question is, in which one of these two lines is the object speeding up? This one or this one? Well, speeding up is increasing speed. Increasing speed needs an increasing slope. Which of these slopes is increasing? This one here. In this one, the line is flattening out and the slope is getting lower and lower and lower. It's becoming more and more shallow, whereas here the slope is getting more and more steep. Increasing slope, increasing speed. So for dy versus time, your graph should look like this. Alright, let's look at the velocity versus time graphs. Remember, the slope represents acceleration. So for the x direction, let's think about the acceleration in the x direction, and let's think about what the velocity is doing in the x direction. Talk about those two things with your partner, or think about them very quick. What is the acceleration in the x direction, and what is velocity in the x direction doing? Pause the video and talk about that. Okay, let's come back now. Velocity versus time graph in the x direction. Hopefully you were able to remember that in the x direction there is no acceleration, there's constant velocity. So if there's no acceleration in the x direction, that means that there should be no slope in the x direction. Acceleration is 0. Acceleration equals 0 for the x direction. Therefore, the slope should equal 0. So if the slope equals 0, the question is, what does a slope of 0 look like? And hopefully you remember from math class that it is a straight line all the way across, horizontal. The question is, does the line need to be here? Does it need to be here? Or does it need to be here? Talk about those three with your partner or think about it very quick. Pause the video now. All right. Hopefully you know it's not this one. This would mean this is where velocity is 0. That can't be the case because the object is moving in the x direction. So velocity can't be 0 if we're moving. So we're left with these two. And what's the difference between these two? Well, these are negative velocities down here, and these are positive velocities. So the question is, in the x direction, do we have a negative or positive velocity? Well, by convention, we decided that the x direction is a positive velocity. We've never made Vx negative. So we're going to make it positive. We're going to decide that this object is moving in a positive direction. So it's not going to be this negative one. If you decide that you want Vx to move in the negative direction, be my guest, but your calculations will be just a little bit more complicated. So my preference is for Vx versus t to look like this. Same vein of thought, use the same logic to talk about v in the y direction versus t. Talk about that with your partner or in your own head right now. Pause the video. Okay. In the y direction, Vy, so here's our graph again. Vy over t. In the y direction, we know that because of gravity, acceleration is negative 9.8 meters per second squared. And the slope of this graph represents acceleration. So I know that the slope is also negative 9.8. So if the slope is negative, that means the line is moving at an angle something like this. It has a negative slope. All right, so I know it's got to be moving in that direction. And the second question is, in the y direction, what is velocity doing? Increasing or decreasing? Well, the velocity is increasing, the speed is increasing rather, because gravity is causing this object to speed up. It's gaining speed in the y direction as it goes. This is 0, and increasing speed on a velocity versus time graph, all that means is we must be moving away from the 0 point to be increasing in speed. All right, so we got to have a negative slope. Our line has to be moving away from the 0 point. And what about the line? Is it going to be a straight line or is it going to be a curved line? Well, a straight line would be a constant slope, and a curved line would be a non-constant slope. So the question is our acceleration in the y direction constant or non-constant? And to answer that question, I might ask you another. If I was to drop an object from some height, what is the acceleration here? And what is the acceleration here? Think about that for a second. Talk about that with your partner. Pause the video. All right, hopefully you remembered, you don't have to think too hard about this, that the acceleration here is negative 9.8, just the same as it is right here. The acceleration due to gravity never changes. It doesn't matter where you are. It's constant acceleration all the way to the ground, not constant velocity. It's changing velocity because of this acceleration, but the acceleration itself never changes, which means we are going to have a straight line, constant acceleration. So I know I have a straight line that is negatively sloped, that's moving away from 0, and so the question is, there's only one line that could be. Straight line, negatively sloped, moving away from 0 is got to be this right here. We can't do that here. That's a negative slope, but that's moving towards 0. That can't be the case. This is moving away from 0, but that's a positive slope. That can't be the case. This is the only one it can be. And notice that this is a negative velocity. These are negative velocity values, which is correct because this is a negative velocity. The object is moving downward. In our projectile, the y components of our velocity are always going down because this object is falling toward the earth. So for our last graph, Vy versus t, we should have something that looks like this.